Greetings! Following an important mission management team meeting on Tuesday afternoon, NASA has announced a path forward for the Artemis 1 launch. Liftoff is now targeted for the opening of a 2-hour window at 2:17 p.m. Eastern Daylight Time on Saturday, September 3rd. Right now, the forecast calls for a 60% chance of violating launch weather criteria at some point during the window, but the meteorologist said that the shower activity would be scattered and could offer the opportunity of clear breaks for a launch. The post-meeting audio teleconference with Mission Manager Mike Sarafin, Launch Director Charlie Blackwell Thompson, and Marshals John Honeycutt, Manager of the SLS program, lasted for a full hour. The introductory remarks failed to explain the go-forward plan or its rationale. Dogged questioning from the assembled reporters, however, eventually prompted important answers about how NASA will proceed. The bottom line is this. Although the data review is continuing, engineers believe that the temperature sensor on Engine 3 may not be accurate. Honeycutt said the physics of the bleed flow and other temperature and sensor readings point to a bad sensor rather than a failure to properly chill that engine. Access to change out the sensor on the pad is difficult and would be best done in the VAB, so that option is not available to allow launch during this window. In an attempt to duplicate the successful chill-down of all 4 engines that was achieved at the Stennis Space Center for the Green Run static fire, the process will start about 30 to 45 minutes earlier than on Monday, during the hydrogen fast fill phase. On Monday, the chill-down did not begin until the tank was in stable replenish. Presumably, the earlier start will give the engines added time to chill and operators more time to evaluate the sensor data. The target temperature for the engines is about minus 420 degrees Fahrenheit, close to the temperature of the liquid hydrogen. Mike Sarafin apologized for providing an erroneous number, minus 500 Rankine, during the Monday briefing. Engines 1, 2, and 4 were at about minus 410 degrees Fahrenheit, while the Engine 3 reading refused to go below minus 380 degrees, about 40 degrees warmer than the target. Although the bleed line to Engine 3 is the longest of the engines, Honeycutt reported that all 4 lines have an equal resistance path. The sensors were installed with engines at the factory and have not been calibrated since. He noted that in his experience with cryogenic rocket engines, these sensors, which he said are development flight instrumentation, not regulation flight sensors, can fail and provide erratic readings. As the team continues to analyze their data, they are building the flight rationale necessary to fly with an out-of-criteria reading on the sensor. Blackwell Thompson said the control team will use the engineering rationale to implement a revised launch commit criteria. It will incorporate updated thinking on the whole set of sensor data, including bleed interface temperatures and ground-side downstream data, and be implemented in the LCC and the ground launch sequencer software. The changes would then be practiced in the firing room before the countdown commences. Just before the press conference, NASA's television feed showed work platforms being placed at the pad. It marked the start of several shifts of work to deal with another issue, the continued problem of hydrogen leakage in the Tail Service Mast Umbilical, TSMU, purge can. Leakage from this connection led to the scrub of a wet dress rehearsal earlier. On Monday, controllers varied the flow rate to cold soak the connection and managed to seal the leak. Now, technicians will retorque the seal on the flange, conduct inspections, perform a leak check, and implement some unspecified modifications. This additional pad work pushed the launch attempt from Friday to Saturday. Another issue from Monday was leakage on the intertank vent quick disconnect. Blackwell Thompson explained that this was not a hardware problem, but merely the result of flowing higher pressure supercold fuel after the disconnect had warmed up substantially while in replenish. This unique condition would not exist in a normal count, and they don't expect the problem to recur. So the question arises, suppose they think the sensor is wrong, but it's actually correct for some reason that is not apparent now. What are the consequences of the slightly higher temperature to engine start and operation? We don't have any specific answers to this vital matter, but we can refer to the generic issue of the reason for engine chill down. The book Operation of a Cryogenic Rocket Engine states the following, quote, "A propulsion system running on cryogenic fluids has to pass a chill down phase before ignition. This chill down is indispensable, particularly if the propulsion system has turbopumps to deliver the extremely cold fluids. The feed lines, turbopumps, valves, and ducts of the engine have to be brought down to the temperature of the cryogenic fluid. During the hot run, the turbopump delivers the fluid at high rotational speed. Starting the pump without prior chill down would cause cavitation, vapor bubbles produced in the stream. The bearings would not have sufficient cooling, and the fuel or oxidizer would be pumped into the chamber with an unacceptably high fraction of bubbles and gas. Turbopump cavitation, as you might expect, can cause what aviation folks call a bad day. An additional concern might be damaging thermal shock to engine components. A relevant question, therefore, is whether there is historical test data or modeling to analyze the real-world risk of a 40-degree temperature disparity. Perhaps NASA can supply an answer before Saturday. Presumably, the flight rationale will provide complete assurance that the engine will be at the desired operating temperature regardless of the sensor reading.
With the Dow down about 300 points, stocks were off for the third consecutive day. 3 of our watchlist stocks were up slightly, and Rocket Lab was unchanged. Oceaneering International, Astrotech, and Momentus took the largest hits.